Let's start Unit 3. That first section, following Khan Academy. Wait, if I draw on this, does it see those drawings on? Yeah, it does. Okay, cool. So we're going to talk about what a composite function is, what is chain rule, and derivatives of exponents and bases that are not e and natural log. So did the warm-up. All right, so composite functions. So the way, I don't know how she described this last year, but the way idea of a composite function is I have something inside and then I have something outside. I will post this online. So, and this is the first part for chain rule. You have to identify what is my outside function and what is my inside. So typically the inside is like what's under the square root, what's between the parentheses, what's inside the trig portion. So I think sometimes students have a hard time identifying that. And I think you get it with some practice. So let's take, for example, this number 1. I have the quantity x squared minus 3 to the second power. So what would be on the outside would be something squared. So the way I'm going to write this is something squared. And what would be on the inside is whatever's in parentheses, x squared minus 3. So I'm just doing this now for practice just to identify these types of things. Next one right here, sine of 3x. What's on the outside? It's sine of something. And on the inside is that 3x. And so typically what's inside parentheses will be the inside. For this one right here. Okay, this can get a little trickier. I would say the outside, so we have a square root and we have a cubed part. I would say both the square root and the cubed are on the outside. All right? Now, if you just said just the square root was here and then the inside is 3x squared minus x squared cubed, you're technically correct because it's on the inside, but you also have a second layer of inside. So I actually wouldn't do it that way. I would treat this as the outside. I'm even going to change this to the 3/2 power. I would rather combine those because that's how you would derive it, because that's the intention of this. And then the inside is 3x squared minus x. And, if you have any questions, interrupt me anytime. Okay. Feel free to stop. I hear music. Silly on us. Okay. Just wasn't my jam. Otherwise, I would have kept going. All right. So let's talk about the derivative. So we talked about doing composite functions, identifying it. Well, now when you derive them. So the idea is that if your y is f of g of x, where g of x are inside function, f's are outside, then y prime is f. Oops. I hate it when I have to switch. Stupid. It's f prime of g of x. You might have seen this notation before. Times g prime of x. Now, another way I've seen this in another form like this. So this is typically what I would write. Another way I've seen this is if its derivative is written this way. F prime of u times u prime, where u is the inside function. I don't know what you've seen before, but both ways are correct. So the way I describe this is I say derive the outside, then derive the inside. Wait, no. Derive the outside, then you times deriving the inside. That would be kind of the way I think about it. If you want to write it like that, in my words, you do the derivative of the outside times the derivative of the inside. Was there another explanation that you heard from your teacher, from Morado last year? You guys? Yep. Either way, if your teacher did it differently, you'd like to understand it that way, great. I don't care. So that's the kind of formula right there. What is it? I think a lot of this is just have to do some practice, though. So what does it look like with those three? So what I'm going to do is identify the outside. So the derivative of the outside times the derivative of the inside. So the outside, remember, I'm not going to write this again. It was some, I like writing it like this. It was, I got to do this again. Okay, there we go. It was something squared, right? So it's something squared, and the inside was x squared minus 3. So the way I would derive it, the derivative of something squared is 2 times that something, and our something is x squared minus 3, and then times the derivative of this thing, which would be 2x. I'm just going to put it in parentheses. So that'd be my answer to this. Now, you could clean this up and say it's 4x times x squared minus 3. And you could distribute that and say it's 4x cubed minus 12x. Okay. Sure. What's neat about this problem, and I want to show you. Now, I didn't have to do this chain rule. What if you expanded this out first? Treat it as an x squared minus 3 times an x squared minus 3. If you expand that, you would get x to the 4th minus 6x squared plus 9. And then your y prime would be 4x cubed minus 12x plus 0. Hey, they match up. That's a good way to check. So yes, it worked out. So you could expand it, but typically problems like this, it's just a squared. Maybe you could expand it if you wanted to not chain rule, but this was like to the 3rd or 4th power. That gets super gross. Let's try the next one below. Sine of 3x, the derivative of the outside. So remember, the outside is sine of something. And the inside was 3x. So then when I derive this, it's going to be cosine of 3x times the derivative of that, 3. And if you want to write it like 3 cosine of 3x, typically that's, we put the coefficient first, but this is still a correct answer. Now the last one, I would rewrite this one as 3x squared minus x to the 3/2 power. And our outside in this case was something to the 3/2 power. The inside was 3x squared minus x. So if you derive those right here, what you're going to get is 3/2 times the inside, 3x squared minus x to the 1/2 power, times derivative of this, 6x minus x minus 1. It looks like a 1, sure. So there you go. Did you make it a square root? Sure. I don't care. All right. Sometimes I think the challenge is identifying those. Let's say if we did these other ones. Okay. So if you're watching the video at home, you can pause and try yourselves. But let's look at number 4. So sometimes it's not as obvious of what's inside. And that's where we get with these ones. Like the other ones may be obvious. Like what's on the outside and inside, or is there an outside and inside? And yes, there is in this case. This one I'm going to rewrite as it's the same thing as cosine of x squared. So this is one of those little traps that doesn't look like a chain rule sometimes. They're easy to put on an AP test. It's gotcha. So it's our outside would be something squared and the inside's cosine of x. So the actual derivative of this would be 2 times cosine of x times derivative of cosine, which is negative sine of x. Could you leave it like that? Sure. Want to write it as negative 2 cosine of x? Sinks. Go for it. Now, 5 is another tricky one. I've seen people that would just do quotient rule for this. And you can, but it's kind of gross. What I would suggest instead is your outside is chain rule. So your outside is actually like 1 over something. So your something is this thing in the denominator. And your inside is 2x plus 1. So if you remember if you have like y is y equals 1 over x, y prime is negative 1 over x squared. So this thing is like your x. So your derivative of this is going to be negative 1 over 2x plus 1 squared. I think that trips people up a lot. And then times the derivative of the top, which is times 2. If you wanted to clean that up, you could say negative 2 over 2x plus 1 squared. But that's what people get. Now, I could do the quotient rule for this. If there was a request to, I could do it for you to demonstrate it gets to the same answer. But if there's not, I'm going to move on. Let you try it yourself. Number 6 is also one of those tricky ones. Okay, so that cubed is like writing sine 4t squared cubed. Okay, so this is one of those cases where sometimes you have like a double chain rule. So your outside is actually like something cubed. And then inside of that is like sine of something. And then it's for, oh well, I'll say x squared since I already started. That's t. So you could have a double chain rule. Could you have a triple chain rule? You could, but that's kind of gross. I don't see them. I don't see that in a normal person doing that. So deriving this, 3 times sine of 4t squared to the squared, because that's the derivative of something cubed. And it'll be times derivative of sine, which is cosine of the inside, 4t squared. I keep trying to type x. And then times derivative of that, 8x. Now, I don't know. If you like organizing it, I don't know if everyone organizes it like me. I don't see people do this a lot. But maybe that helps you out. Typically, if I did the work, I don't think I'd write it out like this, but just kind of showing you for your notes. And whatever's on the inside is boop, 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 inside. So there you go. Gonna move on. Still recording, right? Yes. All right. So sometimes it's not just numbers. Sometimes we put like function values in like this. And I don't know if the Khan Academy assignment does these. No, it actually does these, but it does it with tables. So I'm giving you a lot of information, and it says find this at x equals 2. So this is derivative of, you got a chain rule, p of q of x, right? And we're doing it at x equals 2. So the derivative of that right here. And then basically we're going to use this information to plug certain things in. We might use all of it. We might only use some of it too. We're not necessarily going to use all 5 parts. So derivative of this should be p prime. Oh, that's right. Oh, no. No. Okay. I got to use the annotate. Stupid. The updated Active Inspire doesn't work with my tablet very well. I have to get the older version. All right. So the derivative of that should be p prime of q of x times q prime of x. Right? So, and then at x equals 2. So that will actually be p prime of q of 2. Now, especially when we're doing composites, we're plugging in numbers. You want to write out your work, because this is where things like you try to do it in your head, and you'll fall for the trap. You'll do like p prime of 2 instead of doing, like, we got to do the inside first. So what's q of 2? Q of 2 is going to be right here, is equal to 3. This is actually going to be p prime of 3, and q prime of 2 is 2. Boom, 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 boom. And p prime of 3 is going to be this one. So it'll be 4 times 2. My answer is 8. So stuff like this is typical on APs. This understands your conceptual understanding of how does quotient rule work. The trap is that people would just go p prime of 2. People would do this. They go p prime of 2 times q of 2 times q prime of 2. They would think you're supposed to do this. So they'd be plugging in. You wouldn't even have a p prime of 2. I don't even know what you do. But they would give you good traps in here. And you might just put this one in because you don't know. So watch when you're doing these kind of problems. I like writing out these steps too. Kind of keeps track of what you're doing for your work. All right. Hey, derivative exponential. So that was chain rule. The other thing they throw in really quick, we done derivative e to the x last time. And I think I also talked bases other than e, but I guess I was too early on this. Bases other than e. So derivative a to the x is a to the x times ln of a. That's how it works out. So if you had derivative of 2 to the x, it'd be 2 to the x times ln of 2. Natural log of 2, whatever. Ln of 2. I like saying ln. Did your teacher, did Murado say ln or natural log? That's too many syllables. Yeah. I say ln. I think I've had teachers say ln before. But I think saying that makes me look stupid. Because I bet a real math teacher would be like, well, it's the natural log. Or it's log base e, if you want to say it that way. Yeah. You know what? We find our voice. Thank you. I'm calling it ln. Thank you. So, so we can do chain rule. So, let's take the case of 3 right up here. If I said, come on. If I said in number 3, your outside is e to the something, and the inside is x squared minus 3x. So my y prime would be e to that something, x squared minus 3x, because derivative of e to the x is e, times 2x minus 3. Boom. Let's take 5. Ugh. Okay, so my outside is 3 to the something, and the inside we can leave as square root of v. So my f prime of v is 3 to the square root of v times ln of 3. Do you know? Okay, so this is one thing worth memorizing. Y prime is 1 over 2 square root of x. It's power rule, and you want to do all the steps, convert, great. Memorize this. It's going to save your life so much. 2 times square root of v. Would I simplify that? No. That's gross. All right. Now the other one, last thing here. What about logs of different bases? Well, we have ln of x, and if you don't know, that's... Okay, you remember a few things with log? So ln of x is the same thing as log based e of x, right? You might know that notation. I don't know. If you don't, review. Another thing, if you hear just... Does anyone remember if you have just log of x, what like the default like invisible base is? Does anyone know what that's supposed to be? Curious if you do. Log based what? You can type it in chat too. Okay, Justin knows. He would. Yeah, so like if you're on a calculator and you see like the log button, well, it means log base 10. So the linn button would be log base d. Log base 10, what's that really used for? I think there's some like engineering purposes and stuff. It seems like a lot of times we actually just use log base d for a lot of practical purposes, but I think log base 10 is also used for a few practical things. So that's why it's kind of like the default, like square root 2 is the default root. I don't know. So we know derivative ln of x is 1 over x. If you have a basis other than e, 1 over x ln of a. Okay, so I don't see this happen too much. I feel like this is a jerk problem to throw at you. Because who does this? Like, who does bases other than a all the time? Other than that. So if I did a derivative of a log of x, like if I did this, this would be like, hey, I want to trap you. Derivative of log of x. It's 1 over x log base 10 of a. Oh, wait. No. Derivative, it would be 1 over x times log of 10. It's whatever that a is in there. So that might be one of those trap answers. Like, I had the formula right here. I just messed it up. So they would throw that at you, and you wouldn't remember that's base 10. Haha. So that's how that works. I hope those don't pop up too much. Oh, what? Let's see what I did for bonus time. Are you ready for bonus time? Oh, this has been a long day. Let's see what this is about. I'm not sure if this is relevant right now. Okay, so I think I want to start this. I'll start the Kahoot tomorrow. But since we're getting into logs, okay, properties of logs might be important to remember. If we're deriving logs, these might come up right now. I don't know if they're going to come up in the current assignment. And calculus is trying to move away from making you do these because that's like a pre-calculus skill. Okay. I do have this question. Oh, we can't do this yet because we haven't done implicit differentiation. So this is too advanced right now. But do you remember how to derive these things? And maybe you don't, and that's fine. But we have to save this for when we learn implicit differentiation, which will be later this week. I'm going to stop recording. We're done with the video.